So I welcome you all to this year's ICN IoT panel, which I have the pleasure to share. This year, the thoughts behind this IoT panel were in the early days of wireless sensor networks around the year 2000, we had something that was called directed diffusion from UCLA and was also named a data-centric networking. Then around 2010, we had ICN in the IoT with IoT area, and it became increasingly a subject. In 2020, we have CoAP plus Proxy plus OSCORE. That is also data-centric and IoT. So we have a lot of solutions that actually center around the same elements. And the question of this panel shall be: are we ready to really build a data-centric Web of Things, not only design solutions? And we are very happy to have a very wide-spanning group of experts here. I start in alphabetical order, not to get any bias in here. So our first name is Christian Amsüss. He comes bottom up to this subject. He's a free software developer, right maintainer, long-term coder in this IoT area. He's also an IETF protocol developer, in particular in the CoAP working group. And he's also a startup entrepreneur in the IoT. So he has actually hands-on experience from coding to protocol development. So next in the alphabet is Jari Arkko. I guess everybody knows him. He's a senior researcher at Ericsson. He was IETF chair. He's a member of the Internet Architecture Board. And he's also an early IoT constructor. I believe Jari was one of the first persons who built his home with IoT, all kinds of IoT appliances. So the next in the row is Nikos Fotiou. He is a postdoc at Athens University of Economics and Business, works with George Poulizois. George is, I guess, very well known here, and I guess Nikos is also very well known here. He has a focus on ICN and IoT, and in particular, he's a security researcher, so he's very strong in the security focus, brings the security focus in here. And last but not least, Dirk. I don't know what I need to tell about Dirk, but he's a ICN researcher since the early days. He was co-developer of NetInf. He's IC Energy co-chair. And since, I don't know, 2 years or 3 years, he's a professor for networking in the Emden Leer in Germany.
Thank you.
So I'm glad to have you here. And the way we want to proceed is that we start with short position statements of each of our experts, and then we discuss questions from that arise here or from, in particular, the audience. So please put questions in the chat. So our first speaker is Jari.
Thank you. And hello, everyone. I think we can move to slide number 2 already. So I just wanted to come to this from a sort of a high-level top-down view and talk about where are we. And I guess today we're using, I lost the screen sharing, by the way, on my end at least. Today we are using IoT technologies for many different things, from personal to corporate things and societal things. We expect that to change to even more advanced applications going forward. For instance, having various AI machines talk to each other over the networks and sending IoT data. Next slide, please. And some of the practices that we're doing today, or seem to be following mostly for most of the things that are happening. We seem to have this pattern where everything is in the cloud or goes via the cloud. Of course, that's great, but also has some limitations. We also have made great progress in communication security. TLS turned on for almost everything, TLS 1.3, great improvements, but also doesn't do everything. We're also starting to see new data-oriented processes and processing in various kinds of applications, maybe not adjusting the architecture yet, but at least getting there. We also have some challenges. This week I was impacted by yet another server leak when my DNS provider leaked all their information. Nice. But that happens more often than not. It's not the communication that's the problem typically, but it's the server side. We also have commercial surveillance, as we've seen recently, for instance, in the Washington Post article about where you're being tracked by Facebook. We also have technology where the interaction models aren't necessarily the perfect fit for the problem at hand, and some of this discussion about like where do you put security layers and so on is one example of that. Next slide, please. And so I wanted to bring up three opportunities basically, and the first one is kind of the obvious setup in the panel description already, so I won't talk too much about it. But we can use the web model in new ways or the right ways. So we say we can use CoAP Observe, we can use data object security, we can use OSCORE, various kinds of other transmission mechanisms. So we should actually do this. And so the answer from my perspective, the question of the panel is yes, we can. Of course, it's not like a necessarily yes, no answer. We need to progress. There's multiple aspects. Next slide, please. So one part of this multiple aspects is that just because we protect things from the proxy doesn't mean that we protect it against everything. So one of the trends that I see going forward is that we need to go beyond communication security, protecting data also at rest and possibly also in use. And some of the tools that we could use for this, oblivious protocols, if you attend the IETF, you've seen a couple of proposals in this space for oblivious DNS, for instance, and oblivious HTTP. Another tool that I personally played with quite a bit is confidential computing, where you can sort of encrypt your processes and not even let the computer owner know what's going on necessarily, or not leak the data from the process, at least not randomly, but in a very designed manner to the owner or the person who runs the service. Next slide, please. And the third opportunity is sensing in networks. And this comes through my background. I nowadays mostly work with my colleagues at Ericsson Research, working on sort of 6G-ish topics or future evolution of 5G networks. And one of the things that we've been looking at is this thing called joint communication and sensing. You have this capability of base stations to actually observe the environment without any devices. And I think this is a great opportunity also for some of these protocol designs and information-based information flows, because this basically needs massive data flows. Like you could imagine the base stations are a little bit like radars, or little radars that get information, and that needs to be shared and processed and used for pattern matching and detection, and security needs to be applied in a very careful manner, and results need to be conveyed to applications. This is very different from what we've done in the past in any of these things, whether it's CoAP protocols or networking with 5G or whatever. So it's an opportunity. I think that's it for me. I'll let others continue. Thank you.
Thank you, Jari. I guess we proceed with the next speaker. The next speaker will be Nikos, and we do the discussion and the questions after all speakers have had the chance to position themselves.
Thank you for inviting me in this panel. So, with respect to the panel question, my opinion is that we are already using the Internet of Things in a data set as if it was data-centric, but in reality it isn't. And this mismatch between our perception of the Internet of Things and between what is happening in reality creates many issues. And I would like to focus on the security issues of this mismatch. But let me begin with my conclusion. I cannot tell for sure if we are ready to build a data-centric Internet of Things, but definitely we need one. And let me justify my opinion by presenting you my Christmas IoT setup. So if you have kids in your house, you celebrate Christmas from November until the end of January. So I have set up a small IoT network, which is composed of an Alexa Echo device, a smart bubble by Philips, and a smart plug by TP-Link, in which I have connected the lights of my Christmas tree. So when me or somebody else from the family says, Alexa, turn on Christmas, or lights turn on, and they turn off automatically at 6 in the morning. So from my perspective, all of these IoT devices communicate with each other directly. I'm able to group them, and I'm able to send messages to this group using real-world semantics. And moreover, these IoT devices receive input from the physical world and act upon this issue. But of course, the reality is much, much more different. So in reality, my commands are transmitted to some applications executed in Amazon Cloud, and these applications communicate with the cloud management systems of each device, and finally, these cloud management systems communicate with my devices. And from a security perspective, the reality is equally complex. So I'm having 3 different accounts, one for my Amazon device and one for each IoT device. And these accounts are linked together using WAF2 and a bearer flat token. And but in IoT there exists complex trust relationships, and trying to secure this trust relationship using flat mechanisms that carry no semantics creates problems. So this paper, presenting in last year's Unix, identified such problems in real-world systems. So I will briefly present you one of them related to trust delegation. So the authors identified an IoT system and which can be managed either by a cloud-based IoT management directly or through a home IoT gateway. So typically a user interacts with his home IoT gateway. The home IoT gateway talks with a cloud-based management system, and the IoT device is managed. Now, a user can give access to a second user, and this second user authorizes her own IoT gateway. And she can access the IoT system through her gateway. And so far, this is a legitimate use of the system. But the problem starts when user A delegates the access from user B. And now user B cannot communicate with the cloud-based management system, but she can still access the IoT device using her home gateway. And we can argue that we have trust solutions that can be used for solving such issues, especially when we are talking in the context of ICN. But things get much more complex when we take physical world into consideration. And unfortunately, many IoT systems are affected by the real world. And if we neglect that, catastrophic things may happen. So a very common example is an example of a smart house or a smart factory which uses a fire detector. The fire detector detects a fire and instructs the fire extinguishers to spray water. But in that house, there is also a water leak detector that detects the water and instructs the water system to switch off. And this happens because the water leak detector is not able to, doesn't know that there is an ongoing fire. So I see a chance here for data-centric IoT. The mechanism developed in this community can help us build tools that will allow us to ask things like, is there a fire? And this would be done in an interoperable and secure way. So that's all from my side.
Yeah, thank you, Nikos. We continue with Christian. Christian will immediately jump in here.
My take on this question is to first start around, do we maybe have something in there? And I think we've heard enough about this already to say that, yes, there is a lot of data centricity already in the Internet of Things as we deploy these days. But I'd like to look a bit closer into where this is and how we can get from what there is already to the stage where we have holistically data-centric Internet of Things. The example that I'm picking here, but there are many others, is the use of CoAP for IT applications, where in many applications what we do already looks quite a lot like data-centric Internet of Things applications, or data centricity as it is described. That is, we have a particular thing, a particular datum or stream of data that is assigned a name, and that can be obtained from that source of the information. This is not only in the CoAP stack as described at IETF, but also deployed, for example, end-to-end. Other deployed applications probably use similar things. None of them all the way through, but many at least in some components. So how do we get from there? Current applications are often focused around verticals. So we have like this. We have sensors that talk to their own cloud system at the one side, and applications that interact with that other part only through those server-to-server connections. And I think that focusing on this information centricity can help realizing advantages there, which is basically building on all the work that has happened in information-centric networks throughout the last years. And if we can show and enable these small changes, then we can evolve a system like this into something that more and more resembles some form of ideal information-centric. So, for example, we can start small by adjusting names between those ecosystems so that we have client names and thus need less management to get from one to the next. And then as information gets introduced to the system, participants learn to use more pieces of that information. They can, for example, learn that, hey, this particular site can be reached over the internet at this location. I'm very consciously mixing a few technologies here because I don't think that it matters which particular technologies are involved there, but more that we build on what is there already and help shape that into something that is more information-centric. Because if in the next step we overcome some kind of protocol limitation and the device might learn to participate in a, for example, information-centric network, local mesh network that might already have been used up to that gateway from which data is forwarded on, then a device can suddenly learn to interact with that network on a more local level. Now, whether that is the right or the most efficient way towards data-centric Internet of Things that gets widely deployed, I can tell, and that's what I hope to get out of this discussion, to get a broader feeling of whether stepwise evolution is a good path there, as opposed to building up new systems that have all those many new features. But we'll see. Of course, there are tons of difficulties along the way. So just a few. We need to have aligned data models, because just because two things are talking, they are talking about the temperature and the same units, and this is only the easiest part of it. When we start using names in different ecosystems, they will overlap. We get aliasing, we get all the security trouble that comes from having different names for the same thing. That is speaking nothing of all those protocol. So there's a lot of work ahead of us if we want to go from where we are now to a data-centric Internet of Things. But I think that piece by piece, it's possible.
Okay, thanks a lot, Christian. And It's now Dirk who can do the final view on in this first round.
Yes. Okay. Yeah. Thanks for inviting me. Yeah, I was kind of anticipating Christian's talk, and I decided to spoil the data-centric happiness a little bit. So using this is our grumpy Confucius in Germany. Yeah, I was kind of taking a slightly skeptical attitude here because actually I don't really understand what you mean by data-centric IoT. It sounds like a big convergence or something. And I mean, we have, unfortunately, we have enough irritating names already, like CCN, ICN, NDN, and so on. And so I want to know, what do we mean by data-centric IoT? And so I wanted to discuss this a little bit here. So, I mean, just to remind us, so what we so typically understand when we talk about ICN is this, like the CCNX NDN model of accessing named data in the network. So opposed to the, say, IP forwarding model where we have like a super simple like forwarding services and then some layers on top. And so especially things like traffic steering and things like caching happens at other layers. And so this like accessing named data, that's the core of say most of them, like the mainstream ICN work these days. And so there are some consequences and like the architectures that we are also talking about today expose things like symmetric and stateful forwarding. So I'm not going to explain this, but just to remind us. And of course, object-based security. So we are actually talking about accessing authenticated named data, and we can do other things like encryption as well. And so this is actually the key for many of the other features that we typically cherish in ICN. So location independence, cacheability, and so on. And so network caching is sometimes has been like characterized as like the main feature in ICN, but in reality it's just a side effect of our object-based security model and accessing named data. Because we can replicate data anywhere and authenticate it independent of the location or of the source we got it from. So this means that so also all of the, say, other features that we are typically interested in, like multipass communication or implicit multicast distribution, smarter forwarding planes, and so on. So these are actually more like secondary properties, and the first principle in like most of the ICN systems is really this accessing authenticated named data core, and that's, I think, quite important to keep in mind. And so when we now think about some ICN IoT scenarios, so this is just some like one arbitrary figure where we assume that we have maybe like islands of constrained radio networks, so maybe some low power network, and then want to say maybe run applications that kind of talk end to end, so an ICN way to these nodes. I think it could be quite interesting to think about, so what does this really entail? So given the, say, basic ICN properties that I briefly listed before. So for example, would routing look like in this way when like these nodes pop up in all these different islands? Quite often these power constrained systems, they also employ like push-based models. So how would this interaction look like? So I'm not saying it's impossible, but I think these are interesting challenges and questions. We have heard about interesting things like trust schema, automatic authorization, these kind of things. And then we also have, I think, interesting new approaches to application APIs. And so, for example, like data set synchronization enables a new way to like deal with asynchronously produced data. And so I think what is interesting in doing IoT in ICN is that, well, you have a fundamentally more empowered forwarding model. So you can do many of the things that are typically interesting in ICT, in IoT. So, you know, have special forwarding strategies to accommodate radio network properties. Caching typically helps with robustness and availability. In some networks, you don't need routing. You can discover things dynamically and so on. And so I remembered last year's presentation. So so Günwan and Al, so Christian was also a co-author, where they had this thought experiment. Can you do an like ICN-ish IoT network just using CoAP proxies and OSCORE secured payloads? And at the time, I already had some questions, and I have a few more now. So in general, I think, well, of course, you can build these networks, but you also have to compare apples to apples when you come to your conclusions. For example, when you build up these proxy chains, well, I mean, they also need some kind of forwarding information. So you need some kind of routing approach to that. How would this look like when there are topology changes? Reliability and performance with CoAP's stop and wait approach. I think this also needs some further thoughts. So the comparison in that paper kind of had really good results, but I think only for very carefully selected scenarios. And so concluding, I would say data-centric IoT, are we ready? Well, I mean, first of all, I think ICN provides several attractive features for IoT. So with, like I mentioned, this is like so-called network intelligence that can kind of allow us to have better application support in the network without requiring any application-specific knowledge in the network, which is, of course, what we don't want. So hard coding that application knowledge into the systems. And so, but most of these benefits are really fundamentally based on this accessing named data primitive. And so the larger discussion, I think, that is behind this is that we sometimes, you know, think that or there are many systems that, you know, have something to do with accessing data objects or requesting data objects and so on. And so we take them as information-centric or data-centric. But to be honest, I don't think so. So not every system that is featuring object requests is necessarily information-centric. And so similarly, this OSCORE CoAP proxy network, you can make it to look like an ICN network, but it's not semantically equivalent out of the box. I mean, maybe it doesn't have to be, but for a fair comparison. So you need additional per hop behavior, possibly dynamic routing, and so on. And so I was thinking, so if you go down all that way, why bother with CoAP in the first place? So I could imagine there are some like interop arguments, but remember, you would have to change many things anyway. And so concluding, I would say, yeah, data-centric IoT, sure. But I think what's much more interesting than this message syntax questions or this employing existing protocols is the actual semantics. So how could we design like new types of IoT applications, and so how can we design the function split between the network and the application layer, for example?
Yeah, thanks, Dirk. That was deep into several details. There are a couple of comments in the Slack already from Dave and from Christian. I didn't see an immediate question, so I would like to start with a more, more general question which is quite related to the subject. Namely, Jari was indicating that in a lot of situations, and also in these 6.3 networks, you have sensors that basically continuously report somehow some data. So you're sensing data and you're reporting these data to some cloud somewhere. And my question is, what is actually the appropriate IoT use case for sensor data? So there's this reporting. There's also the ICN approach, which is request a name, request something, and then get a response. And there's also, to add to this even more radical approach, I recently learned from Henning Schulzrinne. He's working on something that's called Zen SQL, and he believes that most of the IoT sensor data is actually not interesting, and you only should like using SQL statements collect your data from the IoT device if you need them. So question is, and I guess you're only four. We can just talk if you want to comment on this.
Yeah, maybe on the first thought. So sensors producing data versus the say ICN request response model. I don't think that it's a real contradiction, because even if you have sensors that are producing data all the time, you still have to think about how to transport the data reliably. So there will be the equivalent of acknowledgements and so on. So there will typically always be some kind of bidirectional communication. And we have seen how you can model this with ICN. And if you think about things like dataset synchronization, which could also be a useful way to deal with asynchronously produced data. Sure, you have some overhead, but the question is, what is what costs are you willing to accept, and how well does this bidirectional communication work?
But the question was more for the use case. For what is useful in the IoT? What do we really need? Not so much how we build this with protocols.
I think that's a really good question. I think the answer is that it's usually not the sort of measured quantity directly that's useful for end use. It's somehow processed. And maybe we have a bit of a shift happening here, that we used to have like this, and all of us have been playing with like this temperature sensors, and I go read the temperature now. But maybe that's not the thing that people want to do. Like networks today measure themselves, and I suspect the same will be true of IoT, that they're like continuous measurements, and then you detect patterns there, and that's like an AI process perhaps. And I think we will see more of these rich sensing devices that can see images, and then you do image processing instead of a detector that sees a movement in a place, but rather you do it with images. I think that brings us to a situation where we have streams of data, and the question is, what is the best arrangement for processing such huge streams of data? Can you stick it all in Kafka and then look at it later? I don't know if that's right. Probably not.
IoT is also a really, really broad field, right? So, you have to maybe be a bit more specific. What do you mean? So smart home versus industrial IoT and so on.
Yeah, the use case is of course sensing here, but sensing is still broad. I know, I agree. Yeah, Christian, do you have any opinion on this?
Thinking back of the presentation that you mentioned about this querying, I think this will be to some extent also a question of where do we want to store the data. So if we have applications where we can, as was suggested there, move the simplification or the actual processing of the data down to the producers, then this would sure reduce the total amount of communication by quite a lot. to the point where we might not even build all the capacity for doing what we do now. That is streaming all the data into the cloud and storing it there in cold storage and hoping to some point find a tool to process it. And then the question is, do we really need to store that, or can we not build our systems in such a way that we either have a question and then we get the data as far out as we need to answer that question, or not get the data out at all?
Yeah, no, I agree. I think so. That's what I had in mind. So, like thinking about interesting, new semantics and interaction models. And so you mentioned Henning's SenseQL idea. So yeah, so if you can go beyond like plain, having like maybe you name data and you access the data directly towards a model where you can send function expressions, something like in a named function networking style, or like remote method invocation style. And so that's what GraphQL is doing, for example. And I think that could be a model if you have a network that can execute these expressions. And in ICN, you could maybe design a system. Well, maybe not all nodes are able to really execute these expressions, but maybe they don't have to if other nodes can proxy for them. And so if there's a system that works like this. So I think this is the named function networking idea.
Okay, now thanks. I guess we have a, sorry?
So it's just a small comment. The CoAP protocol already has considered headers that allow users to specify criteria based on which the CoAP server should respond or not. For example, a CoAP client may specify that I want to read your temperature only if it is greater than a particular value. And this is part of the standard. And this becomes even more interesting if we combine CoAP with other extensions like CoAP Observe or even CoAP group communication. And I think then it becomes very interesting who performs these computations. Will it be the IoT devices themselves? Will it be the network? Will it be some proxy? And also a very interesting question is how can we make sure that the result that we received is the correct output of the computation which we specified.
Okay, now we have the first questions in the chat from Karen Zollins. To all of you, what are the metrics that you think reflect good or improved IoT behaviors? This is important for figuring out whether or not new approaches are useful. That's what Karen asks. So what is actually what counts? What are the relevant measures you would suggest?
Yeah, I mean, for many years we have focused a lot on, say, communication efficiency, implementation efficiency, and I mean these things are going to be important, of course, but perhaps these are not the only things. So I think in the future it would be more relevant, say, how easy is it to build reliable, secure, trustworthy applications, and so to include different sources, maybe under different authoritative control and so on. And so I think that this is for me an interesting metric. So how easy is that going to be?
Yeah, Dirk, I agree with you, and I think that's exactly right. I'll add a little bit. I think the traditional metrics are like latency and communication efficiency, but I would also add the ability to do new things. If you get let's say the video stream or whatever, how much can you configure it? Can you use it for detecting new things that were not built in by the manufacturer or designer?
And I think that it does not have to be super new things. For example, implementing CoAP group communication, which is an RFC using existing technologies, is cumbersome. The RFC recommends the use of IP multicast, and then you have to have modified DNS entries that map each CoAP group to an IP multicast address and things like that. If there was a technology that would facilitate the creation of groups of IoT devices, that would enable very useful applications.
I would consider two distinct metrics. The one is what Dirk already introduced, basically the usability. Can you work with it easily? The other is depending on the application, but always can you pull it off? So that might be in sensor networks energy expenditure. Can you do this without rolling out hundreds of batteries and changing them every few years or not? So this boils down to some of the efficiency measurements mentioned earlier, but in the end, it's just, can it work for this application, or are there any overheads, any impracticalities that make this particular application work?
Okay, we have more questions in the chat. So one is from Pavan. That's a long question, and that is about deviating from the interest data model for some applications. So that is, can we have more push-based applications while maintaining the interest data model for the other set of applications where it makes sense to do it that way? Whoops, it's difficult to read. In which case, a good direction of research could be to distinguish an application requirement into one of these two sets. So that means interest data and push, especially for the application requirement where the line is blurry. This is a very difficult question. I'm not sure if someone wants to answer on this. If not, we jump to the next one. Anybody?
I can speak to this if you want.
Yeah, you can say maybe a brief answer. It's a very ICN specific question.
Yeah, but we can also discuss it more generally. So yeah, I mean, of course, we know that so push sometimes happens when you have asynchronously produced sensors and power saving regimes and so on. On the other hand, I mean, for like the security goals that Karen also mentioned, Kathleen mentioned, sometimes, I mean, you don't want to accept any pushed message. So sometimes there is actually a value in having an indirection and maybe, you know, asking the producer, also the actual producer to, yeah, maybe trigger some request response interaction later. If you cannot do that, so in like power constrained networks, so if these are so like edge networks, for example, and I mean, it's not necessarily a problem if you have if you deviate. So my view, if you deviate a little bit from the interest data scheme there, and you could enable so an enhanced forwarder that accepts these messages. Given that the sources and maybe the data can be authenticated and you can avoid some attacks. So this is maybe a bit detailed, but I think they have just really different ways of dealing with the problem.
I'd like to answer this question from the perspective of the work that Dirk mentioned that we did last year. I think that here we can learn a lot from the CoAP ecosystem, because there these kind of pushes as a response to an interest but going on happen a lot in these observations, and as long as some boundary conditions are met, like you're talking about eventually consistent data, and the data is still on the topic, which also means that this needs to be about mutable data. So it's not working with all information-centric network models. Then I think there's a lot we learn from just how it's used there and how it works there.
There are more comments? Otherwise, we can switch to the next question from Nicole. That is, what about DDoS or DOS resistance? How important is DOS resistance? Is this a key issue here, or is it just a side issue?
Probably doesn't have to be DOS attacks only. There are also other.
There are other ways to.
You can imagine. Yeah, so
yeah, it's not just DOS; it's also access to your data and other attacks. But I think it is a key issue and needs to be addressed.
And so it's consensus that this is a key measure of the quality of a solution, right? Maybe we can.
Yeah, right. I mean, it's a key feature, and I mean, in general, of course, we know some ways how to do that. Sometimes they are quite costly in IoT and so on. I think the question is, maybe a bit, say, the context that where you try to do this. So I think maybe what has been in the background here is, if you have like more open environments where things come together and are reused in other application contexts and so on. Of course, there are quite some attack vectors. But if you want to have this, ease of application development and recomposition and so on, then attack resistance is a #1 priority, of course. So you need to trust the data that you get, and if somebody else, has attacked the source or the data in transit, then big problem.
I think that I would add to this metric attacks enabled by the IoT. We have, for example, the Mirai botnet, this IoT-based denial of service attacks. And of course, there is a wide range of privacy-related attacks that are enabled due to the IoT. So it will be interesting to see if a new protocol introduces a new attack as well.
That actually poses another question, and that is about the right way of protecting data or the right security model. So I mean, from the web, we know a TLS as basically the solution. So the transport layer security is as an end-to-end session between the server and the client is basically everywhere. So the question is this also the right DTLS? Is this the right way, or do we need something else? Is actually content object security the better or the worse here?
At least, in my opinion, we need something more. And there is an excellent paper presented in 2018 in ACM CCS called Situational Access Control in the Internet of Things. And there they examine the case of these trigger event systems that perform some operations based on the context of the user. And they consider the example of a system that performs some actions based on the location of the user. So the way to implement this right now is to continuously ask for the current position of the user. And of course, this is a very significant privacy threat. We need something in between the user and all of these systems that hides the context of the user and reveal it only when certain conditions are met. And I think this is a requirement that does not exist in current internet application, and this is very IoT specific.
And it does play right into the topic of trusted computation, some particular points at the edge, which then again, in a model where there is just TLS as the single of transport protection, would not even see. And so we gain some, we lose some. We need to trust other systems more in order to be able to trust the systems we trust now less.
Yeah, so I agree that confidentiality is also a major problem, and of course this is sometimes more challenging in say data-centric environment, especially in like our ICN-based systems. So we have some solutions for name privacy and so on. Often they involve intermediaries. So I agree that this deserves more thought. So how would actual systems really look like, and how can we avoid that it's in the end, turning out as a chain of proxies again, and so then maybe many of the proclaimed benefits would also disappear eventually. And so quite often we focus on, say low-hanging fruits and say individual or specific aspects. But if you would design a say complete system for maybe a non-trivial application environment, then you have to think of all of these hard questions. And of course, it's not easy, but it has to be done.
Okay.
Let me just briefly note here that this is a good point that speaks very clearly against an evolutionary model from current IoT deployments towards a information-centric system, because you can't just get these complete rethinking through small single steps.
Okay, we are running a little bit out of time, so there's no new question if I saw correctly on the chat. So I would like to conclude with one question for all of you, each of you, and this is more a visionary question. That is, if you imagine 5 years from now, what would you expect IoT networking in the field? We expect IoT networking massively in the field. What would you expect to be the dominant way or the dominant technique? How would it look like? What will be special or not special?
Okay, so I'll bite. So I assume you still have the sensing background, and I'm thinking that there would still be a plethora of different systems, and maybe there wouldn't be like one uniform system for all environments, and it's quite okay. So if you think about like some special systems like LoRa, for example, and you could imagine that so it's not using IP or anything today, and doesn't really need it. But you could think about so these island systems that still use their own protocols, and so for that part of IoT, I could imagine that it will you will still see this in the future as well.
So you're expecting a heterogeneous deployment, right?
Yeah, perhaps including some ICN approaches as well.
I'm with Dirk on expecting that there will not be just one predominant thing, but just the same mix with hopefully a few faces in there as we have now. What I do hope that we can have in 5 years is a bit of a more consolidated understanding of the data on the abstract levels, so that can exchange more easily, at least between these different applications, the data we get out of the systems. Be in the process of buying a bit below that. 5 years, the ecosystem is fragmented now.
And I also agree that we will see a heterogeneous situation in 5 years from now, and 5 years is not that long actually for major changes. But if I'd have to guess, I'd say that the sort of things built on top of the web are, playing a major role. And also we tend to think about stuff like at the lower layers, what radio and what IP and what what protocol on top of IP. But I think the upper part of the thing is also quite relevant, like who actually gets this data and how is it processed and how is it protected, and is the OSCORE protection through various middlewares or it's ending at the Google data center that stores everybody's IoT data. I don't know the answer to that. I hope we will have more enterprise and person-owned things than large company-owned data stores.
I believe that in the near future we will see IoT deployments targeting to solve urgent worldwide problems. I have in mind climate change and their impacts, and for this we need accurate, fast measurements from areas probably isolated, like forests, seas, deep sea. I see also as a scenario the prevention of a new pandemic. And probably in this direction, we will see more immersive IoT devices, which probably will jeopardize our privacy, or there will be a new privacy attack vector. So I'm hoping for new solutions that will, actually protect us against devices, and will make sure that IoT devices are used for a good purpose.
Okay, this is actually a very nice conclusion. Yeah, thank you very much. Thank you all. Thanks all of you. I guess we have touched quite a range of aspects, and also quite controversial, which is good. So thanks again, everybody, and I hope you continue to enjoy the conference and also continue the discussion in the Slack.